Okay, Assalamualaikum dan salam sejahtera. Okay, so hopefully you can understand and then you have the idea how to sketch the root lockers. Okay, for the root locker, basically, first you need to know the starting point and point. Okay, meaning that you need to know where the root lockers are. And then the second one is you need to find the asymptote. Okay, the point asymptote, the angle of asymptote, and then the j omega intercept. Okay, for the asymptote. Okay, and then the next is you need to find the waypoint. Okay, this one is the point you want to sketch the root lockers, and the lastly you want to find the j omega intercept because you want to find the final graph for the root lockers. Okay, so for the frequency and gain at imaginary axis. Okay, so how you solve. Okay, so here I want to explain to you, okay, how to solve. Okay, so okay, in this example, they ask for the range of k, and then for stable system, and then find the root lockers cross the imaginary axis. Okay, this one is the simple, bukan simple, this one the previous example, the same block diagram, the same open loop transfer function. Okay, you have a 1, 0 and then 4 poles. Okay, okay, so what you should do first, okay, you expand the denominator, and then the lastly you get s power of 4. Okay, you get this one, s power of 4 plus 7 s power of 3 plus 14 s power of 2 plus 8 plus k multiply s, and then the last one 3k. And then this one you need to arrange in root table. Okay, so that's why the root table is important for the root lockers. Okay, so you susunlah macam ni kan. Okay, so s power 4, s power 3 until s power 0, and then susun the first row, the second row, and then this one is a b1, b2, c1 and d1. Okay, so here, okay, so you after that you need to know, you need to find the value for k because you want to find the s here. Okay, okay, so 21k greater than 0, so meaning that k greater than 0. Okay, the first one, and then the second one is you solve this one, minus k square minus 65k plus 720 divided by 90 minus k greater than 0. Okay, so you akan dapat something this one. Okay, yang dia explain kat sini. Okay, only the S1 row can give a row of 0. Okay, pastikan dia akan dapat ni, row of 0. Okay, kalau untuk this one, okay, the second one ni tak boleh sebab kita ada two value kat sini. Okay, so tak boleh nak solve. Okay, so and then, okay, and then you dah dapat value k. Okay, sebab this one is a k power square, so maksudnya dia adakan two value. Okay, one is a negative, one is positive. Okay, so you ambil yang positive. Okay, sebab kita tahu untuk root lockers, value dia mesti kita consider above 0. Okay, and then apabila you get the value for k, and then you sum kita cakap you substitute, okay, in this second row. Okay, so 90 minus k s power of 2 plus 21k, and then you just put the value of k here, and then you can get 80.35 s power of 2 plus 202.7 equals 0. Okay, and then from here you need to find the s. Okay, so and then after you calculate this one, you can get S1 S2 equal plus minus J 1.59. Okay, make sure this value is less than J omega intercept for asymptote. Okay, kalau lebih besar tu maksudnya something wrong lah, maksudnya awak salah calculate ke apa kan. Okay, So this one adalah dia punya value intercept dekat J omega J omega AZ. So kalau awak tengok, awak akan dapat something like this lah. Okay, this one. Okay, so this one is a 1.59. Okay, this one is a break-in. This one is a breakaway point. Okay, so inilah kita katakan dia adalah root locus. Okay, ini yang penting yang kita nak draw. Okay, ini adalah first step. Okay, the second step. Okay, the third step, and then the last one is a fourth step. Okay. Okay, so and then the last, the range. Okay, so you can found that 0 k equal k between 0 and 9.65. Okay, this one. Okay, dia punya range. Okay, the maximum. Kalau maksudnya k greater than 6 point ataupun 10 is the system can unstable. Okay. Okay, the last rule in the root locus, kita ada angle of departure. Okay, angle departure is a focus on pole. Kita ada satu lagi, angle of arrival. Okay, this one for the zero. Okay, so kalau tengok first kena dapatkan this one. Okay, so you can see here, you ada 1, 0, and then this one is a real 0, and then this one 3 pole, and then 1 is a real pole, and then 2 is a complex pole. Okay, so paling senang you draw dulu dia punya this one. Okay, draw dulu this one, and then you akan nampak lah. Okay, dengan dia punya theta. Okay, theta 1, theta 2, theta 3, theta 4. Okay, untuk theta 2, theta 3, theta 4 ni you boleh nampak. Okay, you boleh calculate guna trigonometric equation. Okay, for example this one you can use tangent kan. Okay, sama juga dengan theta 4. Boleh dapat daripada tangent. Okay, so and then you kena cari theta 1. Okay, nak cari theta 1, you apply this equation. Okay. Okay, so this equation. Okay, so maksudnya minus theta 1 minus theta 2 plus theta 3 minus theta 4. Okay, kalau nice dia nampak beza, kalau ogata dia nampak beza sikit lah kalau untuk zero. Okay, okay, this one okay, kalau minus tu adalah untuk pole. Okay, this one pole, and then this one pole. Kalau positive ni adalah untuk zero. Okay, so the value dia boleh guna trigonometry, and then this one equal dengan 180. And then you calculate this one, you akan dapatlah jawapan something like this. Okay. Okay, that's all for the angle of departure. Okay, itu adalah angle of departure. Okay. Okay, another example 6.1 for Ogata. Okay, so this one you can see the textbook Ogata, and then you can find the answer. Okay, you can find the answer for this one. Okay, so for the Ogata, dia sangat detail dia punya solution. Tapi mungkin ada few yang akan buat juga confused. Okay, so boleh pergi detail dekat Ogata. And then this one for the complex conjugate. Okay, so sama juga. So boleh boleh tengok pada Ogata textbook. Okay. Okay, then boleh try for this example. Okay, and the last topic in root locus, kita nak tahu what the effect of the addition of pole. Okay, so here, so you can see, okay, so this one is a one pole. Okay, so basically kalau kita tahu pole belah kiri, so the system is stable. But if you add more pole, dia akan jadi tend to the right. Okay, so maksudnya dia makin jadi tak stabil. Okay, dia kata tending to the lower system stability and to slow down the settling of the response. Okay, so maksudnya lagi banyak you tambah pole lagi tak stabil lah kan. Okay, and then the addition of zero, what happen? Okay, dia adalah vice versa dengan addition of pole. Okay, so the addition of zero to the open transfer function has the effect of pulling the root locus to the left, tending to make the system more stable and to speed up the settling of the response. So maksudnya dia vice versa. Okay, so you can see the figure for the last. Okay, okay, this one is all the pole, and then if you add 1 0, so dia akan 10 to the left. Okay, tukar dia punya condition. Okay, so dia akan lagi ni. Okay, dia punya this one, curve dia akan lagi more stable. And then if you put the 0 to another side, okay, here, so dia akan lagi 10 to the left. Okay, I think that's all for the root locus. Hopefully you can understand. And then I have one question, and then you need to answer and give to me and then you solve and give to me. Okay, I put the first, okay, one exercise to you in Google Classroom. Okay, that's all. Thank you. Hopefully you can understand, and then next we can move to the next chapter. Okay, the last chapter is a frequency response. Okay, hopefully you understand and enjoy the root locus. Okay, thank you. Assalamualaikum and salam sejahtera.